So today we are talking about molarity, the two different ways that you can measure molarity, and then we're also going to talk about how you would determine if you have a concentration of one liquid, how you would change it into a different concentration by doing some sort of dilution. Okay, but anyway, I am going to go ahead and share the whiteboard. Okay. That where it needs to be. All right. That over here. All right. So first things first, let's talk about, okay, molarity. So molarity is the number of moles of solute per liter of solution. Okay, and like I said, moles of solute dissolved. Okay, per liter of solution. And so we have a couple different ways that you can measure this. And the first one's going to be the one that we are more familiar with. This is going to be moles solute divided by liters solution will give you molarity. Okay, and that's always, we measure that, or we mark that down as a big M. All right, so molarity is a big M. So let's go ahead and just do a practice problem with this one. Again, something you guys should be pretty familiar with. And so let's go ahead and say that we have a 100.5 milliliter intravenous solution. Okay, so we know our liters of solution is 100.5 milliliters. Okay, contains 5.1 grams of glucose, which is C6H12O6. Okay. What is the molarity of this solution? All right. And then it gives us that the molar mass of glucose. So molar mass of glucose is 180.16 grams per mole. Okay, so we need to find molarity. Easy enough. First thing we're going to do is turn 5.10 grams of C6H12O6, and we will turn that into moles of that, okay? And so this will be times 1 mole C6H12O6, okay, divided by 180.16 grams per mole of the same thing. Okay, and so when you do that, this should come out to be 0.0283 moles glucose. Okay, so we know how many moles of glucose. Now, what we need to do is punch this into that equation, the molarity equation. But there's one other thing that we should do before we do that, okay? So our molarity equation up here is moles of solute, which we have moles of solute now, divided by liters of solution, okay? What is this in currently?
Milliliters.
Yeah, perfect. And so what we do is we 1, 2, 3. So this is actually going to be 0.1005 liters. Okay, easy enough. Now we come back down here. So we're going to have 0.0283 moles divided by, you can actually put that as mole, divided by 0.1005 liters, okay? And what that will leave me with is I will have a 0.282 molar solution. Okay, my molarity is 0.282 because all I did was divide this by this. And that obviously is pretty easy to kind of mathematically check off. Obviously, you would kind of say, yeah, this makes sense that I would probably just move it over 1, and then that 5 over here, just a small amount with a rounding, drops this from 283 to 282. But we can see, does everybody see how this works? Again, we've kind of gone over this way to do molarity before. I just wanted to check and see if anybody had any questions. Okay. All right. If nobody has any questions about that, I will. Is anybody like taking notes, or can I clear this? Because I mean, this will be up on a YouTube later that you guys can look at if you need to. Okay. I'm going to clear this then. Throw up the text. All right. And so another way that you can do this is molarity. You can also do it as a ratio of number of moles of diluted, not diluted, dissolved solute in 1 kilogram of solvent. Okay, so instead we could measure per thing of solvent. Okay, so let's just say in the lab, a student adds, so we have a mass of 4.5 grams of sodium chloride, NaCl. Okay, so this is mass of, I'll just type mass of solute. Okay, so we know that is added to 100 grams of water. Okay, and so we know mass of solvent is equal to 100.0 grams of H2O. Okay. God, I keep wanting to type 0 instead of an actual O. All right, so we know these two things, and what we want to figure out is essentially the moles per kilogram. Okay, so there's a couple things we can do first. We know we're going to have to change this into moles. Okay, and so really fast, I'll give you the molar mass of NaCl is going to be 58.44 grams per mole. Okay, and we can change this, right? Because this is per kilogram. So how many kilograms of water is 100 grams? It is 1/10. Okay, and technically, since there are the 3 zeros behind it, due to this decimal point with the 0 behind it, that does make this significant. So we got 4 sig figs there, so we have 0.1000 kilograms of H2O. Okay, so now we have to turn 4.5, so 4.5 grams NaCl. We're going to multiply that times 1 gram, or sorry, 1 mole NaCl per every 58.44 grams of NaCl. Okay, and when you essentially just divide 4.5 by 58.44, you will get 0.077 moles NaCl. Okay, so now we have, for this, again, let me put this up here. So molarity is equal to mole of solute divided by kilogram of solvent. Okay, so we have our kilograms of our solvent right here. We have our moles of solute right there. And so now all we got to do is plug those things into our equation and chug, little plug and chug. So we've got 0.077 mole NaCl, and that is going to be divided by 0.11, or sorry, 0.00 kilograms H2O. Okay, and so essentially what you are going to get here when you plug those in is you'll have 0.77 moles per kilogram. Okay, and that can be moles of NaCl per kilogram of H2O. All right, both of those are molarity things, and it just kind of depends on what you're given. Okay, when you're working with something like this, and you know, with the first one, either one of these are pretty simple to do in a laboratory setting. Whether you have, I mean, you're going to need to figure out your moles of solute either way. But if it's easier for you to do mass of solvent versus the volume of the whole thing, of the whole solution, it's kind of whatever. I think generally more people do the other one, whereas and actually this is more of a lowercase m that they'll usually use. And these are usually italicized, whether it's the uppercase M for the other molarity or this one where it's the lowercase m, they'll be italicized. You can use either one, but again, I think I see generally more people use the first one where it's going to be moles per liter. All right. Are there any questions about molarity? All right. If we have no questions about molarity, then we can move on to the last thing that I had for you guys today, which is just kind of talking about dilutions. So basically how to take, when you have molarity, you're essentially going to take molarity and divide it by a certain, or molarity times a volume. Yeah, it'll make more sense when we actually just do it. Okay, so anyway, I will clear this. All right. So over here, we have, so a dilution. Okay. A dilution is basically taking a solution with a certain molarity and making a new one with weaker molarity. Okay, so the dilution equation is going to be M1, okay, and that'll stand for molarity 1, and this is when we're going to be using, and so molarity used is moles solute divided by liters solution. Okay, this one doesn't really work super well with the other one that we talked about. So you're going to have M1 V1, okay? So that's going to be molarity 1 times volume 1 equals M2 V2, okay? And that is the dilution equation. All right? So, and this is really, really helpful because so a lot of the stuff that we've worked with in the school year this year when we did any labs, say that we were working with hydrochloric acid, a lot of the time we're going to be working with like 1 molar hydrochloric acid. You can buy 1 molar hydrochloric acid. It's not very efficient to buy that. What people generally buy are these really big jugs of like 12 or 24 molar hydrochloric acid. And then as the chemistry teacher, you use this equation to do a dilution. And you'll essentially take a specific amount of your 12 molar and you're going to want to turn that into 1 molar, okay? And so it's pretty easy once you get used to it. But anyway, so let's do a practice problem with dilutions, okay? So if you know the concentration and the volume of the solution you want to prepare, okay, you can calculate the volume of the stock solution you will need, all right? So what volume in milliliters of 2 molar, 2.00 molar calcium chloride stock solution would you use to make 0.5 liters of 0.300 molar calcium chloride solution? Okay, so when I read that, I know that the thing that I'm taking is my stock solution, okay? And it has a molarity, so my M1 is going to equal 2.00 moles of CaCl2. The nice thing about this equation, we don't need to switch anything. You don't have to use molar mass for anything, okay? Because we're just going to be switching. It's going to still be CaCl2 solution. We're just diluting it, okay? What we don't know is our V1, okay? How much of that stock solution are we going to need, okay? Our M2, the dilution molarity that we're trying to reach, is 0.300 moles or molar CaCl2, and the volume, our V2 that we're trying to get to, is 0.50 liters. Okay, so we've got all this stuff. Now all we need to do is plug it in and chug along. Okay, so we have 2.00 molar. We have a V1. We don't know what V1 is, and that's going to equal 0, and we'll put this in parentheses, 0.300 molar times 0.50 liters. Okay, so you can do this a couple different ways. Doesn't really matter to me. I would probably just do this and then divide by moles, okay? So what is 0.300 divided by 0.5? And the answer to that, 0.5. Okay, that's going to be, this will give you, so 2.00 mv1 equals 0.60, and that would technically be what that would be because this only has 2 sig figs, and that's going to be mole per liter, okay? But this will be easy. We can get rid of that mole and just be stuck with liters here as soon as we divide this over, okay? And so we are going to want to take this and divide it over to this side, okay? So our next thing we will have is V1 is equal to 0.60 molar per liter, okay? And that is going to be times, or divided by, excuse me, divided by, and I should put that in parentheses since I already have it divided. Okay, that divided by 2.00 molar, and that will equal 0.0, those are little o's, 0.075 milliliters is going to be equal to, or sorry, liters, is going to be equal to V1. And you can also just put that because 0.075 liters looks a little goofy. So you can put that as 75 milliliters. All right. Does anybody have any questions? Again, this is really just pretty simple algebra stuff. I assume most of you guys should have no problem with this. You all have at least strong enough math background that this stuff is pretty simple. It's easy math. But are there any questions? Cool beans. Sounds good. Okay, so I'm going to stop sharing my screen now. Well, we lost somebody, didn't we? All right.
Joe said it kicked him out, but he's